Yeah, good morning. So today I'd like to present work we've been doing for the Oil and Gas Authority in the UK and also with the MPD in Norway, and how we can basically integrate different data types to extract the information we want from those projects, and therefore it's kind of molecule to seismic and data integration. Today I'll be doing I won't be doing the seismic part today. I'll just be concentrating on the well part, but we can do the seismic at a later date. So we did a large study in the North Sea for the Oil and Gas Authority, partnered by the MPD, where we predicted hydrocarbon pay in 5,400 wells. These are exploration wells and these are production wells. And you can see the map to the to the right there, the distributions of the wells in the project, stretching right from the from block quadrant 210 in the UK, right down to 3 in the UK, and also on the Norwegian side from the Tampen Spur right down to the Sleipner area. There was approximately 30,000 kilometers of basic logs used for this pay prediction. The usual log suites, gamma ray, resistivity, density, DT, and neutron. There was about 155 kilometers of training data. These are CPIs for porosity and water saturation. And in total, there were around about 90 million depth indexes for this project. So this was a true big data project. So what I'm going to show you today is kind of ways of trying to cut and dice this data by using different data types to extract the information that you would like out of this large data set. You know, to go and visualize each well separately will take you a long time, and I think we need to, through EarthNET, you can accelerate this process. Just over up front, very quickly, what a pay interval is. A reservoir, a portion of a reservoir that contains economically producible hydrocarbons. This is the 3410-1 well, the discovery well for Gulfax, drilled in 78. We see here quite nicely our sand prediction within the Brent. We see our porosity predictions, reservoir style porosity around about, say, 20 to 30%. And in blue and in red, we have water saturation, low water saturations in those high porosity intervals, and that's, of course, classified as pay. So I'm just going to show you the amounts of data in the project. So this is all the wells on the left-hand side is all the wells with predicted pay in the data set. And you can see there are many, many wells there. For the right-hand side, there is dry wells, wells that have been reported by the operator within the OGA or MPD databases, which are registered as dry. And this is where we have found we have predicted pay in these wells. On kind of a well scale, just sort of put this in as an example for you to get used to what we're doing. This is a well from the UK sector in quadrant 211. What we have here is, because we are predicting sand in the Tarbert netted Essive and Rannoch formations. In blue, there is the porosity. You see reservoir style porosity between 10 and 20%. We see reduced water saturation with the red curve. We have a pay flag based on cutoffs from porosity and water saturation. And of course, we have a whole condition flag as well. And what's interesting about this well was in the OGA website, you go in and this well was registered as dry. It was drilled in 91 by Mobil. So we can see here that within the active, there is pay. But again, this hole was registered as dry in these large databases. So this was interesting for us. And if you just Google this well, for example, on the OGA website, there's a relinquishment report by Zeno who concluded there was probably an oil column in this well. This well is this red dot here, and that the oil down to or the free water level up to is beyond the limit of the local fault closure, indicating potentially there is a larger prospect stretching northwards. So this kind of shows you the power of the technique in terms of trying to identify pay. And of course, the term mispay has been bandied around. And is this an example of mispay? Certainly mispay to me, but obviously not mispay to Zenor. So the definition of mispay is quite flexible. So the data types that we're going to use to try and extract information we want from those 5,400 wells. Of course, we can be using lithologies, formations. We'll be using the porosity curve and the water saturation curves to derive pay classes. Also, we have a database internally. We've constructed this, gleaned this information from various sources, completion reports, the NPD website, for example, where we have gross column height. So the pink area is where we have hydrocarbons present, registered in various reports. And then we have an area where there's no hydrocarbons reported. So we're able to kind of filter on that. And also on the far column to the right, we have an oil shows database. And of course, where we have, pay, for example, we might expect it to be an oil shows. Because we know that oil shows descriptions by the operations geologists can be quite ambiguous at times, and these oil shows databases are not the complete story. I think it goes some way to finding a consistent story through diverse data sets to identify our different pay intervals. I just want to talk about pay classification. So what I've done here is I've taken our predicted porosity and our predicted water saturation curves, and I applied cutoffs based upon those two curves. And the cutoffs I've used form, for example, pay class 1, 2, 3, 4, 5, and a non-pay class. And you can see on the diagram to the top right here the different pay classes I've done. And I'm going to be using these pay classes to extract the information that I would like. So now what I want to do is I want to go to a live demo of EarthNET to show you how easy it is to extract this information from those 5,400 wells. I'm just going to go here, and I will, and I'm hoping you all see EarthNET. So what I've done is, this is EarthNET, and this is a module called map plots. This is where we can do all our visualization. And what I've done is I've loaded all the wells into the project, what I call the OGTC master project. So this is all our wells in the project. I'm going to go to this panel here where the cursor is, and I'm going to bring up a well set of all dry wells in the Norwegian sector. There we go. And all this data is coming from the cloud. So none of it is local, it's all from the cloud. What I've done here where cursor is, I've selected pay class 1, 2, and 3. I'll just select them again. So this is where we have low water saturation and high porosity between 10 and 30%, for example. The column height is just going to be measured depth, and I'm just going to press update. So what it's doing now is rifling through the database on the servers in Europe, and it's bringing up this information. Gives us information here on each individual well. We click that off, and so what we have here is dry wells. Well, wells have been registered as dry by the operator, and although we have identified pay in that well. Another way to do this, of course, is we can have our different pay classes on, but we could also have another category called oil show. So the thinking being is that if there's going to be a predicted pay, then we would like to have an oil show registered with it. So we can click on all of these. I'll just drag this down, shift, selecting everything, and I'll just press update again. So the next image we'll see is dry wells where we predicted pay, and they are oil shows, and you can see there's 3 wells. Our oil shows database is not extensive, but because we do know that oil companies do have oil show databases and growth column databases at their fingertips, which can be easily imported into EarthNET. So here we have 2 wells, or sorry, 3 wells. I'll just click on those wells. We'll just take the first one, the 33-12-5 well. So what I'm going to do here is, so I can I'm just going to go into a Wellbore Plot. And what I'm wanting to do now is then look at that data in a Wellbore Plot. So search on the well 33-12-5 comes up automatically. I'm going to then just load in my logs, lithology. These are all the lithology models I ran in the project. I'll just choose one master log that shows lithology. Then I'm going to load in my porosity, porosity mean, my water saturation mean, gross column heights, and I'll put in my hydrocarbon shows. I'll just write in shows and hopefully it'll capture that. And because I will just make this large fonts so you can all see it, press update, taking all the data from the server. Just make this a little larger for you guys so you can have a look. So what's interesting for me is I see a hydrocarbon anomaly here. I'm just going to zoom in on this interval here. So the top says is undefined, but it lies between Chromanol and Lunda. So I'm guessing it could easily either be Triassic or Jurassic. We don't know. We're predicting porosity around about 20% and water saturations about 0.6%. So it's just on that threshold. We see there was no column registered in the on the NPD website, but we do see associated with oil shows. So that's interesting stuff. And this well lies just to the east of Statfield Field, the big billion-barrel field, Statfield. So you can see how easy it is to basically drill into the data and glean the data that you would like. I'll just go back to my presentation now. Slideshow. So now I want to kind of give you a few examples now. So what we have here is wells in the Norwegian sector where we have predicted pay in hydrocarbon columns using our gross column height. So fundamentally, we should be predicting pay where a column has been recognized, and we do that. You can see a lot of those wells plot on existing discoveries. So it kind of gives us credibility that immediately we are predicting hydrocarbons where we have hydrocarbon columns. And of course, an example is the 34-10-1 well. I've shown this before. We have our gross hydrocarbon column gleaned from the information from completion reports, and we see the oil. We see the pay being predicted within that zone. So also what we can do, we can do wells in the UK sector, in the Norwegian sector in our project, pay outside of registered oil columns. So if you remember, if you just go back one step, it's all pay in this purple area. So that's interesting itself, is that we're getting pay outside those main producing units. And of course, that's really interesting. To have that type of information. An example, of course, is the 34-10-1 well. Of course, we've shown this major pay zone in the Brent, but there's 2 intervals here with low water saturation, high porosities, and we're predicting sand. And these are sands within the Lister Formation. Operator tested this in 2012, and they come out with a resource of between 40 to 150 million barrels recoverable in the Lister Formation. So that's really interesting because a lot of companies, of course, are focused on the main producing asset. In this case, is the Brent Group, and maybe are forgetting some of these large, some of these smaller pay intervals which may be economic present day. So looking at pay intervals outside existing producing intervals is really quite interesting. Of course, dry wells with predicted pay. I've shown you that before. These are all dry wells, so we can see what wells those are, and then we can bring this data up in Wellbore Plot. An example is the 1532 well. This was classified as dry on the NPD website. It drilled in 77, so it's a fairly old well. It's a fairly deep well. What we have is upper Jurassic sands being predicted. We have porosities associated with those sands, and we have predicted lower water saturations. And of course, we come out with a pay classification here. So if you go to the completion report, four sand bodies have been identified. They do have low porosities. You can see our porosity cutoff there, around about say 8 to 10%. Some reach at the base hit 12%. Oil shows have been recognised. Also, there's high gas in the mud. The upper two sections were tested with DST, but it was unsuccessful. But what's interesting for me is this well was registered as a dry well on the NPD website, and obviously it's not dry. So, kind of, mistakes or errors in databases could lead us up the wrong pathway here. Another well, which was classified as dry, the 33 well. You see map insight on the far right. Predicting sand in the nest formation and in the active porosities associated with that sand. We have lower water saturations in the nest formation. What I'm interested in this is in the breadth, is in the active. Just at the top of the active here, we have a spike of low water saturation, which we're registering as pay here. And of course, that's interesting. A 1-2 meter interval is interesting. Can lead to a larger discovery, or potentially this is a migration pathway. And then, of course, I've showed you before in that demo is dry wells with predicted hydrocarbon pay, where we have oil shows, and we can have these examples here. So our oil shows database is not complete, but you can show the power of mixing these databases to extract all this relevant information. So an example here is the 3312-5 well east of Statfjord. You see there's sand in the upper Jurassic, reservoir style porosities 20%, low water saturation, pay being identified, and there are minor oil shows associated with this interval. Another thing we can do is, of course, is do dry wells and have pay water saturation between 0.6 and 0.9. So this is not pay in itself, it's basically a smoking gun. And so we can extract that information, and you can see the wells that we identified here. An example is the 3363S well drilled in 2012, predicting sand in the Hansen, Ericsson, and the Raud formations in the lower Jurassic and Triassic. We have porosities associated with those. We have lower water saturations, but these are not classified as pay. But we're having, in that interval there, interestingly, it's registered as poor oil show. So again, this supporting information gives credibility to our predictions. Concluding remarks. Using different data sets, we can cut and slice these huge data sets to extract the information we want pretty fast as well. And of course, what it allows you to do, it allows you to grab that information and focus in very, very quickly on the areas that you'd like. You might have core areas, and you can make a sample set for those core areas, and then you can cut and dice that sample set. Of course, that's the ability to focus, the geoscientist to focus, And also what we're doing, we're trying to find consistent storage through combining different data sets. Of course, consistent storage gives credibility to your observations and to your conclusions. So that really ends the presentation today. And if you'd like any more information, you can either contact us at this email address or contact Sarah directly. That would be great.